Oxygen gas at temperature of P degrees C has a root mean square speed set of 5088 times as large as the root mean square speed of hydrogen gas at Q degrees C. If Q equal to P plus 30, find P. We have two forms of the formulas to find the VRMS. One is in terms of the molar mass of the gas, capital M, and another one is in terms of the small m, which is the mass of the molecule for the gas. In this formula, the R refers to gas constant, and in this formula, the K refers to Boltzmann constant, and the capital T is the temperature. Since we know that the molar mass of oxygen gas is 32 gram per mole, and the molar mass for the hydrogen gas is 2 gram per mole, so it would be easier if we choose this formula to find the VRMS. Now, based on this general formula, we can write down the specific form for the VRMS for the oxygen gas. So in this case, the T, the temperature, since in the questions it is given as P degrees C, we have to convert this temperature into Kelvin. So it is P plus 2 cent 3.15. And M here, now we add a subscript to it to refer to the molar mass of the oxygen. And we call this as equation number 1. The hydrogens, its VRMS, take the similar form, but now the temperature T is substituted by the Q plus 2 cent 3.15. In the questions, the temperature of the hydrogen gas is given as Q degrees C. So in terms of in the Kelvin, then it is Q plus 2 cent 3.15. And the molar mass, now we change the symbol to MH. Subscript H means hydrogens. So we call these equations as the equations number 2. According to the informations given by the questions, we also know that the VRMS for the oxygen gas is equal to x times of the VRMS of the hydrogen gas, where this x takes the value of this, which is the square root of 5/88. We can now substitute the equation number 1 and 2 into these expressions, and we take the square both sides to get rid of the square root sign. So this x will become x squared. Without the square root sign, now we have at the left hand side P plus 2 cent 3.15 divided by molar mass of oxygen, and at the right hand side we have Q plus 2 cent 3.15 divided by the molar mass of the hydrogens. The 3R in the equation 1 and the 3R in the equation 2 has been cancelled out. We can now substitute the value for the molar mass of oxygen, molar mass of the hydrogen's molecule, and the x squared, so that we can reduce the number of symbols in these expressions. Now this x squared will give us 5/88. Molar mass of the oxygen is 32 gram per mole, so in kg it is 32 times 10 to the power of -3. And hydrogen's molar mass is 2 gram per mole, so it is 2 times 10 to the power of -3. So after substitute this value in these expressions, it remains the P and the Q, two unknowns. The 10 to the power of -3 and the 10 to the power of -3 here can be cancelled. And 32, if we bring it to the right hand side of the equality sign, it can be simply divided by 2, we'll get 16. 16 multiplied by 5, it is 80. So 80 divided by 88, we'll have 10/11. We bring this 11 to the left hand side to get 11P plus 11 times 2 cent 3.15. At the right hand side, the 10 multiplied with Q, we have 10Q. Multiplied with this second term in the bracket, we will have 10 times of the 273.15. This Q can be substituted by P plus 30. And the 11 times of the 273.15, we bring it to the right hand side. And this use 10 times of the 273.15 minus 11 times of the 273.15, then we get negative 273.15. And at the left hand side, it remains 11p. Now this 10p, we can bring it to the left. So 11p minus 10p, we obtain p here. And 10 times 30, you get 300 minus 273.15, we'll have 26.85. So it is approximately 27 degrees C. This is the temperature of the oxygen gas. And for the temperature of the hydrogen gas, it is 27 plus 30, it is 57 degrees C. So when these two gases take the temperature of these two values, 27 degrees C and 57 degrees C respectively, the VRMS of the oxygens would be equal to X times of the VRMS of the hydrogen gas, where the X takes the value of square root of 5 over 88.